Alright, in this video, we're going to go over natural log, basically base E. Now, remember, when we were going over continuous problems, things that grow continuously like the world population or bacteria or decomposition or a temperature increase, all these different things that are continuous, we found out E played a pivotal role, which is just 2.71. All right, and we kind of had this function y is equal to e to the t, right? This was just some exponential equation, basically y equals 2.71 to the t. But remember, e is the most important number in the world. It's so important. And so, because it's so important, it gets its own special freaking natural log inverse. Basically, it gets its own inverse function, right? For example, if I told you to find the inverse of this, well, what would you do? Well, the base is e, so you do log base e in parentheses is equal to blank. The y is your output, so that now becomes your input, and the t is your input, so that now becomes your output. But we weren't satisfied, or I should say mathematicians were not satisfied with this because they knew how special e was. And so we said we're going to give it its own special log function, or inverse function. And it actually turns out to be right below the log button is ln, which represents natural log. That's the inverse of e. Let's look at a few examples. Let's say we do f of x is equal to e to the x, all right? Let's plug in 2. E to the 2. What is e to the 2? 2.71 raised to the second power. Well, let's go ahead and do second, and then right before you see the ln, you actually, that's where you get e raised to the 2. And we get 7.389. 7.389. Okay. Well, let's see what happens if we plug in 7.389 into my natural log, what's called ln, 7.389. And watch, I guarantee you, because they're inverses, we are going to get 2 back. Let's do ln. And what I could do is hit second answer. That pretty much is going to take my previous answer and plug it in. And we get 2. You'll see what goes around comes around for these two functions. Therefore, we can conclude y is equal to e to the t and y is equal to natural log of t. You read it as ln. These are inverses of each other's, right? E to the x gets its own special inverse for a lot of reasons. One of the reasons in calculus, you'll one day understand, is the derivative of e to the x is e to the x. That's the only function that does that. All right, well, I'm getting too excited here. Let us begin. With an example, let's convert from exponential to natural, or to logarithmic, but in this case, ln, right? So let's say I got 20 is equal to e to the t. Well, again, the e is my base, the t is my input, and the 20 is my output, right? Well, I do not have to anymore use log. I can use its own special inverse, which is natural log. So just write ln parentheses is equal to blank. And we proceed like we've always done because they're inverses. This is your output that now becomes your input. This is your input that now becomes your output. So if I go to my calculator here and type ln of 20, we're literally going to get our answer. And 2.9957. So t is equal to 2.9957, right? And if we were to take this and plug it back in, you will see we will get pretty close to 20, e to the 2.9957. Let's go ahead and do that real quick. So we get second e to the 2.9957. Okay, and we're gonna get approximately 20. Look, 19.9999. 19.9999. Pretty cool, huh? All right, so let's go through a few example problems converting from exponential to logarithm, or in this case, e to the x to its natural log inverse state. So I don't know, let's say we have, I'll use a different color this time, purple. Why not purple? Let's say 42 is equal to e to the 20t. All right, well, to convert this to logarithmic form, all right, we'll do ln because that's its own special inverse is equal to blank. This is your output. Well, that is going to become your input. And this is your input, so that now becomes your output. Now, what do we do to solve? Well, we can just divide actually 20 to both sides, right? That's how we can get rid of that. And we get t is equal to ln of 42 divided by 20. And let's use that, put that into your calculator, and we'll get our answer, which is right over here. Let's do ln of 42 divided by 20. And we get t is equal to 0.186. So t is equal to 0.186, and that is my answer, right? Let's go through one more example, just introduction, and then the next video we'll go from natural log back to its exponential form, right? So let's do 42 is equal to 20 plus 4 times e to the 2t, something more challenging. Well, what do? Well, in this case, I'll first just subtract 20 to both sides. We want to get rid of that. 42 minus 20 is just going to be 22 is equal to 4 times e to the 2t. Well, what do I do to get rid of the 4 since we're multiplying? Well, we divide by 4. And 22 divided by 4 is 22 divided by 4 is 5.5. So I get 5.5 is equal to e to the 2t. Now to solve this problem, just continuing on, now we just convert it. So we got ln blank is equal to, ln of the input is equal to blank. Well, this is your output, so that now becomes your input, and this is your input, so that now becomes your output. What do you do to get rid of the 2? Well, look, I already put the line there. Let's just divide 2 to both sides. And we get t is equal to ln of 5.5 divided by 2. All right, and I'll let you go ahead and finish that problem off because I'm running out of battery, so I just want to make sure this is exported from my laptop before